Guys, we are going to continue with the chapter we missed out. How come it feels like the sharing is wrong? Basically, going to continue with the chapter. Okay. Everything here we done already, right? All this we discussed already, all the answers. Yeah. Let's move on to the next part, which is the calculation of charge, guys. Listen up. In terms of charges, last week we learned that there's positive charge and negative charge, right? Positive charge and negative charge can be done, and we can actually calculate how much charge flows through a certain object. Let's say, for example, right, if let's say today I have a piece of wire here, around here, and I say that this piece of wire allows 10 amperes of current to flow for a good 5 seconds. I can actually calculate how much charge is flowing through this wire using my first formula, Q equals to IT. If I have Q equals to IT, it's basically I, which is current. This is current, not charge, which is current multiplied by time, right? Which in this case here, I know that there will be a total of 50 coulombs of charge flowing in this wire. This is the first formula. The second formula will be dependent on the number of electrons that flow through the wire. For example, if let's say I have such said wire again, and let's just say in a very unlikely scenario, I have exactly 5 number of electrons flowing through this wire here. Okay. If I have 5 number of electrons flowing through this wire here, in order to calculate how much charge the wire will be flowing, I need to figure out, you don't need to figure out, by the way, let me rephrase. You need to multiply the charge of one single electron with the number of electrons. In this scenario here, this number is actually a constant number. 1.66 times 10 to the power of negative 19 is the charge of one single electron. And of course, if let's say there's only 5 electrons flowing in this scenario here, it will be 5 times 1.66 times 10 to the power of negative 19 right? And I press this in the calculator, I'll get something that will be the amount of charge that is flowing in this wire as well. It should be somewhere around 5.8. Is it? No, it will be 8.3. 8.3. Huh? It will be somewhere around 8.3 times 10 to the power of negative 19, maybe. Times 10 to the power of negative 19 coulombs, guys. This is the amount of charge that will be flowing in the wire. So I have two formulas I introduced today. Q equals to IT, one charge formula. The second formula will be Q equals to NE, number of electrons multiplied by the charge of a single electron, which is the E, which is a constant number. Can? Please attempt the 5 questions right now. No, you will be 90% of the time you'll be given. I saw 1 year they did not give this number, but most of the time they'll give So I don't think you will try to remember this number. In fact, sometimes I forget it as well. This is current, not charge. C is coulombs, A is amperes, S is seconds. This is the units. Where are you going later, Melody? Amen.
Oh, yeah, did you know the you must be what it is? I don't know, you told me you don't know about this one. No, that's you. That's you.
Oh.
millimeter.
1 meter is how many millimeter?
Wait. 1 millimeter is how many meters?
1 meter is how many millimeters? You know you beat you.
1,000.
1,000. So 1 ampere is how many milliamperes? Good. Convert that.
So in this case, it will be like this, right? Wait. So
Wait. Do I owe you a drink? No. So it's you, and you only, right? For the previous test, yes. Current will be amperes. Capital A.
Oh shit.
Check your phone. Where's your phone? No. How much do you get? Let me check.
I will get one.
Eugene, you are far from it.
No.
No. Sit down and check your phone.
Why so normal for you?
Oh yeah.
That's right.
I think he did something. Yeah. Man, okay, you put everyone pay for themselves so they don't have time, right? I need to work, so. I'm paying.
How do I change it?
You think I should do normal or this? What's that? I think it's
Wait, he paid you? For what?
Change it already.
Hey, you actually.
No, it's not.
Yeah, I knew it like a business page. Yeah. Then he paid. He's one of his pay is one.
Hey, this is nice. No, you should. What's the fish name? You should ask the fish Bob. You know it's Bob. Why should I ask Bob? Ask him to do it. Right, nice.
You get the 3.5 including
Teacher, what's the charge? I mean, what's the unit for charge?
C. coulombs.
Oh.
Do you? Really? If you like, do you like peach? Or they don't get it. This one, it's milk tea. Like we legit.
Hello, bác sĩ lão cũng bác điểm lá.
This is like really, yeah. Yeah, like.
She got a fucking boyfriend.
Like your mom feels.
Okay,
Yeah,
right.
this one is like. It's not bad. Yeah, it's good. But she doesn't like.
Is this her
So
Right.
answer it.
Someone.
What's the S? Or the
Right.
Is this a school?
yeah, number of electrons. Is like this. G lah, how many times I teach you already?
No, I mean like some.
You're taking this divided by this, right? But you know when you press the coupler, this will be dividing this and then you will multiply this.
Well, how do I kind
Yeah, no, it's not like negative.
5 is wrong. What the hell? 1000 divided by 200. Yes. 200 is 5 lucky, yeah. That's GG, bro. Yes, that's correct. This is correct already. Yeah.
1.8 crowded.
Oh, 3 centimeters, my friend. 7.23 centimeters, 19.
后面有写多少了？
You never follow it.
Same thing also.
You get to follow it, not go pace.
No.
You also can follow your
Number of electrons, which is this 20 is T. They're both not even in the same formula, you just divide them.
That's how you understand.
Use this first, then use this thing about it. Hey, that already now.
所以浪费钱买都有违法的命。
当然了，这个有法有。
我靠！我反正，你不要我被 call 的。
Who's that talking?
You
Gabriel. Sound like the latest results.
Yeah.
Oh, wait, yeah, I think like, oh, man.
Why?
No.
Okay, this one. Which one does this belong to? Okay, understand. Okay, and this one? Yes. See, they both yes. Yes. Other than this, not. Why don't you use this? But you don't know the structure. We never remember it's still Where's the game about it? On that. No, it's probably like I'll do my answer. Yeah. I see whether we get a two answer. Say, you have something? I answer. No. Are you saying no? No. And no question. It's like that's like my shut up. Express. Shut up. What if I shoot a book? What if I shoot? I haven't get the same answer already. Is it? How about why don't get the same answer anymore? It's just text errors. So you got 31 rows already. We spend instead of the investment, it's not in place again. This is the charge of electron. Shut up. And this one is time. So I just use this formula. Use ID. This is charge. No, but then more people are trying to do. You also are people not how you go into those toilet. But he tried to teach me his way. I was like, no, that's the thing, they don't because the charges might get all like this only this only the charge. This it might be math speaking. Yeah, you also need to pee when you go to toilet. Why not put the reverse toilet? Why not? I get here now. You tried to teach me my answer wrong. No. Shut up, are you?
What's the answer for the
Wrong. 7 point something times 10 to the power of 19.
19?
Yeah. Okay, guys. I've walked around and seen some really horrendous answers, I must say, especially for question number 3 and some question number 5. Okay, question number 1, I think most of you guys got it correct, right? It's basically, hey, for those who are struggling, right, I must emphasize that you use the formula. This is your Q and this is your T, right? Your I will be basically Q over T, right? Which you then press in your calculator, 20 divided by 50, which you'll get 0.4 amperes, right? No, everyone got this correct. Once again, this is your Q, this is your A. You're looking for the time, the time, right? Time will be basically Q over I, right? Which is basically 60 divided by 0.3 and you get 200 seconds, right? Then comes this fateful question. Some of you guys are struggling to even convert this, for which I want to emphasize once again that, hey, what's your answer?
7.23
Okay, lucky you're correct. All right, so you're first supposed to convert this into amperes, which is divided by 1,000. And you know that this is definitely your current, right? Then this is your time, which you're supposed to change into seconds, which you then know is your time. And they already give you this E already. So you're supposed to find the number of electrons, right? You don't know, right? Then you literally plug into the formula Q equals to IT first, which you then take 0.2 multiplied by 60, which you'll get 12 coulombs. Then after that, you want to look for N, right? N will be basically Q over E, right? Which in this case here will be 12 divided by 1.6 times 10 to the power of negative 19. Hey. Oh, you can shut up at the back. What are you doing? Yes, I've seen a lot of you guys, that's correct already. I've seen a lot of you guys, do you know what you guys like to do in the calculator? 12 divided by 1.6 times 10 to the power of negative 19. Do you know in your calculator, they'll divide this first, and then they'll only times this? And that's why some of you guys get a horrendous answer of 7 point something times 10 to the power of negative 19 electrons. Not only is it smaller than 1, it's 0.00000000071 electrons. For those who wrote that, you're not even thinking. It's clearly wrong. Your answer should be what? 7 point? Oh shit. Yes. Okay. Then for question 4, I think most of you guys got it correct also. Is it 20 coulombs? Correct? Q equals IT. And question 5, once again, you have to use 2 formulas, guys. You're given the number of electrons, you're given the time, and you're asked about the current. You're supposed to use Q equals to NE first, which in this case here will be 5 times 10 to the power of 18, multiplied by 1.66 times 10 to the power of negative 19. Then you get something. What's this something? 0.83 coulombs. Then you're looking for the current, right? So I will basically Q over T, which in this case here will be 0.83 divided by 20. And bam, you get your answer already.
It's about 5 times 10 to the power of 18 divided by 1.6. So that one, I saw the 5 something.
Yeah.
Yeah, but you got
Oh, that's right. Equal to, yeah.
What do you get?
0.04.
Huh? 0.83 divided by 20. Then you get?
On by, yeah,
What do you get?
0.6.
4.6. 4.2 4.2 can right? 2 to 3 significant is correct. Okay. Okay, next. Move on. Okay, we're going to talk about a very important basic understanding here, guys. First and foremost, we talk about measuring amperes, which I don't want to dwell too much on. Measuring amperes, I think everyone knows this, right? Ammeters are basically used to measure current, and they must be connected in a series circuit. You all know this, right? Anyone don't know this? What about voltmeters? Can I put it here? Why not? It's parallel. Voltmeters must be parallel, ammeters must be in series. This is the first thing. And now, yes, please try to remember now. Okay, it will not work the other way around. If let's say you have a voltmeter here and then you have an ammeter here, it will not work. Ammeters must be in series. Voltmeters must be in parallel. That's a must. They will not test you, but you need to know. They will not test you why it is like that, but you need to know that they're in series and parallel for ammeters and voltmeters. Huh? What do you mean?
I know.
Okay, can I run?
my school started to drinking for even more schools.
Yeah, they skipped the electricity part. I don't know why.
Talking about degree in my class. Is it?
Where you going?
The alpha, beta, and gamma. The alpha, beta, and gamma is very related to chemistry. That chapter. Luckily, you all are here.
Yeah, yeah,
Oh, they skip the whole chapter. What? Okay, anyways, everyone shut up. Moving on to the next part here. Right, this next part also, you all need to know this. They will ask you this in your exam. You know how when you move, there's friction that is in opposite direction, right? It's the same concept for electron and current. The reason why current can flow in a circuit is because of the movement of electrons in the opposite direction. I want you to associate, guys, when we move forward, our friction is backwards. When the electrons flow forward, the current will be flowing backwards. In fact, on top of that, you need to remember which direction the electron flow and which direction the current flow. Electron will always flow from negative to positive as indicated by this blue color line here. Whereas current will flow from positive to negative as indicated by this red color line here. You need to remember this, guys. Okay? Anyways, nothing much to talk about. Just remember this one. Next, we talk about AC and DC though. You all know what DC stands for and what AC stands for? This plug point here, is it providing AC current or DC current? It's AC. Okay. All our electrical devices, everything has an input of alternating current because our electrical devices will convert it into direct current, like your laptop, your computer, and whatnot. But we all plug into the same point. All these plug points here provide alternating current. There will be a chapter explaining why, but for now, you need to know that DC are basically like battery. The current will only flow in one direction. Okay? The current can only flow in one direction. But for AC, the first cycle of current will flow like this. The second cycle like this. The third cycle like this. Fourth cycle like this, and so on, and so on, and so on, and so on. So it will constantly go clockwise, anti-clockwise, clockwise, anti-clockwise, clockwise, anti-clockwise. What? Oh, that's how alternating current works. It must flow in two directions so that later on, when you learn about transformers, you really know why. But there's a very long description. But I'll tell you why later when we reach the transformer chapter. Okay? No, it's not like a transformer, like this thing, the power brick before your, the power brick before your laptop, that thing is a transformer. Yeah, but we'll talk more about that later on. Okay. And transformers must work from AC. That's why you cannot just like plug a battery to this laptop and start charging it. It doesn't work that way. But anyways, guys, because DC can only flow in one direction, right? You see direct current, right? Will always flow in the positive region. Okay, whereas alternating current, because it flows in alternate cycles, it will flow between negative, positive, negative, positive, and negative, positive region. Okay, if you associate clockwise as positive, then the anti-flow must be negative. Positive, negative, positive, negative, positive, and negative. Okay, right. Keep that in mind first. Right now, you need to know there's two types of current, alternating and direct current. All this builds up to the next few chapters, guys. So just have a good foundation first. Next, we talk about electromotive force and potential difference. Guys, listen up. Voltage, electromotive force, and also potential difference, they are all measured in under volts, guys. Okay? They are all almost the same thing, but they are different. Just like how we don't go into the girls' toilet. Even though we're the same thing, but different. Okay, anyways, listen up. For electromotive force, right, guys, it is usually the power source of the circuit. For example, you look here, this is the electromotive force of the circuit. This is the electromotive force of the circuit. This is the electromotive force of the circuit. Whenever we talk about electromotive force, you just think about the power source of that circuit. And it's because of this power source, it actually allows current to flow in one direction due to the flow of charged electrons. I repeat again now. This electromotive force, right, is the you can't write this in a real exam, but I want you to think about it. Electromotive force is the force that pushes the charge around the circuit, which allows for current to flow ultimately. Okay? Without this thing, then there's nothing to push. You can't write this in a real exam. I say this again. Don't write, oh, electromotive force is the force that pushes the charge around the circuit. You don't write that. You'll get it wrong. But you need to think about this force that pushes these electrons around the circuit. Okay, that's why they call it electromotive force. The real definition of electromotive force is quite challenging and very annoying to remember. Electromotive force is defined as the energy supplied by the source in driving charge around a complete circuit. And because of this definition, the formula for electromotive force electromotive force is the energy needed to drive a Coulomb charge around the circuit. These two formulas are the same thing. Okay, this is voltage, energy, and charge. This one is voltage, work done, and charge only. Get that? Get that? Yeah, energy.
So the EMF,
Yeah. Shit, man, I'm eating too much candy today. I'm eating too much sugar, man, today.
Isn't EMF the thing that you use to talk to ghosts?
Okay. That one, I think the one that talk to ghosts one is a electromagnetic wave, something related to this also. But I'm not exactly sure which one is it. Yeah. By the way, guys, I just want to ask you all for some comment now. Nalisa here has done us a good favor and showed us a design for GTD shirt. Designed by Nalisa. Maybe this one can change a bit because this one a bit more related to us, right? Yeah. Guys, guys, this one, any comments? I mean, it can be any number you want. It can be 4, 7, 8, 9, 10 also can. This one can change one. Want to make this? Huh? I just want to see a show of hands. How many of you guys would be keen to make one of these t-shirts? I need to find out the pricing also, guys. If it's free, will you want it? If you have to pay, will you want it? How much will you be willing to pay for? 2 ringgit. Shit, 2 ringgit. Might as well say free. Wow, bloody hell. Okay, I got a serious question now. If let's say, right, this thing, you need to pay, right? Seriously, how much would you be willing to pay for it?
Usually for eventual, it's 20 with the maybe 40. It's like no, it's was around 20.
20. Okay. But if it's free, how many of you guys want it?
If it's free, I would take it.
Okay. Okay, then let me rephrase. If you have to pay, how many of you guys will want it? Let's say 20 bucks out, we say flat 20. Okay. Okay, all right. Let me send this to my t-shirt guy, and then I'll try to find. Okay, which leads to the next question. This one will be the sleeves, huh? How many of you guys don't want this sleeve? But I hope to have like a, yeah, maybe something like this one.
Then put the one in front.
Which one?
Put this in front.
This one? No lah, I want the logo in front.
Yeah, you add that, bro.
I want the logo in front.
Be your logo.
Huh? No lah, bro. It'll be totally different from what they see online, bro. Inconsistent, bro. This one, okay lah, quite cute lah, right? And this one is like for the corgi lovers. But anyways, you guys want to change this?
No. Can you put your real face in there?
Yeah,
Okay, bro, what is it? Okay.
Yeah, it's just like one is Mr. Gilbert.
No lah, that's cringe, bro. No. No. Definitely no. Okay. All right. Okay. I'll ask my t-shirt guy. It will definitely not be 20 bucks. I can almost guarantee that, but
Subsidy.
we'll subsidize the rest, okay? We'll see how it goes.
The whole thing.
Okay, we'll make a challenge.
What challenge?
I guess
We'll make a challenge if you get we will think about a challenge. If you can complete the challenge, then we'll get it for you for free.
Pass my physics like that.
Pass your head lah. Pass, go back home and watch YouTube lah.
Get A for chemistry.
Can consider?
In school exam.
Can? Okay. Okay, if you can get A for your exams, for any subjects you take here, we'll give it you for free.
Any subject I take here.
It's a 26 changeable.
Of course. It can be a different number.
26.
No lah, it can be any number lah. It can be any number.
No.
Okay, good. Okay. I've thought about it already. You pay 20 bucks first. If you score an A, I'll pay you back the 20.
Okay.
Okay. Right.
Bro, so they sent this one, right? This is the first version. And then I couldn't tell between them. So I started to be more realistic than they give me this.
Show me what is it. Show me.
It is very
Show me.
accurate, man.
Oh my God. Okay, anyways. Okay, I'll go ask my t-shirt guy. Then we'll subsidize the rest.
October.
So, you get back. Think about it as a deposit. If you get your A, then we'll just pay you back. Okay or not? Okay.
I got 4 subjects.
Yeah, just score A for either one. Then you can wear proud and say, 这个我赢回来了。免费的, bro. But anyways, moving on back to this one here. So what's the difference between electromotive force and potential difference? Stop copying, everyone pay attention. Listen up, guys. Potential difference, right? You can think about it like a cake, like a ice cream, like a cake man, cake postman. Okay, whatever. This guy is delivering cake, okay? It starts off with at the factory with 3 pieces of cake. Okay, and en route, he only needs to deliver to 2 people. One person, when he delivers, right, while en route, he still had 3 voltage here, right? And then when he delivered to this house, he delivered 2 voltage here, right? So how much voltage will be left here, by the way? 1. And then before it reached the other house, he delivered the last piece of cake and it'll be left with 0 cakes, right? So going on back to here, right? Listen up, This is how you look at it, guys. Listen up, When you start off at the battery, you will always have the maximum value of the voltage one. It will be 3 volts here. And when you end at the battery, for sure will be 0 volts one. This voltmeter will read the potential difference between these 2 points here. 3 minus 0, that's why it will read 3 volts for sure. Okay? It will be the same for this one also. This voltmeter will read the potential difference between these 2 potential points. It starts off with 3 here, right? And then this guy consumed 2 already. There's only 1 left, right? That's why it's 2 here. Can see, And this one also the same thing. The potential point here and potential point here will basically be 1 and 0. That's why the potential difference is 1 volt. Potential difference measures the voltage consumed by each electrical device. Okay, if there's more, it will distribute even more. Let's say, for example, I give you another example. let's say this is like a battery, sorry, lamp lah. Let's make it easier. Let's say this is 9 volts. How much will the potential point be here? How much will the potential point be here? 6. And how much will the potential point be here? And here will be 0, right? So if I put a voltmeter here, right, it will measure the difference, which is 3. If I put another voltmeter here, it will be 3. And I put another voltmeter here, it will be 3. And I put a voltmeter here, it will read 9 volts. It measures the potential difference in each potential point. You guys get what I mean now, eh? That's the difference between potential difference. Electromotive force, although both of them will be measured in volts, electromotive force is talking about the source, the battery, or any power source. Potential difference is literally the difference in potential between two specific points. Usually, in between the points will be the component. Like either the lamp, the battery, voltmeter, or blah 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 blah. Something. There will be some electrical component there. Okay? Copy this down. Just copy the one on the right, guys. The left is the same thing. Just copy the one on the right. And maybe just include your potential points as well. Then it's easier for you. Hey, the Grab delivery is coming in. Later, one of you guys go down. Okay. Who's 1, 2, 3, 4? Cause they deserve it. Okay, you get it?
Why are you laughing? Bro, that's say that. Say that.
On your machine. Oh. Huh? Who's that teacher?
Stop tuition.
And not the power, although it can create.
Yeah, because of college. But no, when did you text her? When you zoom into the loser at the night? She wait, ask her to wait. Why you wait?
Hey, while waiting for Eugene to come back, copy this down first. This is the next thing already.
Okay, no. The other. You just say that's the same. I think it's
What did she say?
Hey, hurry up, sit down, copy this down first.
we shut up. Look at mine. No.
Sorry, I want to change it to capital I and capital R for the V equals to IR formula.
It's not a point. I gonna go to the meeting. I'm forced to go, bro. Nah, I'm gonna bring food. Yeah, so you bring food for me. No, when you think you are, you're the staff of it. Yeah, you're the staff of it. Yeah. I will bring them.
Stupid.
What did you just say?
Stupid.
What did you just say to?
Oh no, I didn't starve myself. What are all the African kids gonna think about me? Yeah. Oh no, let me starve myself so I can raise awareness while the African kids continue to starve. I had that too when I was young. Some of my friends are like, hey Gabriel, come join us, let's go, man. Let's go. Huh?
This is a hunger.
Yeah. Huh? Not fucking doing that. Why would I do that? What's it gonna do? Like, and that one time also, like, I don't know if you guys still have this or not. You know, like Earth Hour. Do you guys still have Earth Hour? That one, at least it makes sense, right? Like everyone cumulatively turn off their light for 1 hour. Then it actually produces less carbon dioxide in the environment. 1 hour only. But a lot, that cumulatively does a lot on. Actually, it does a lot. That one, okay, I can accept that. Like, and a lot of people actually join on. Okay, done. Done drawing. I want to explain this, guys. This is an extremely important formula, guys. This is basically Ohm's law, which I think, if some of you guys learned this in year 9 already, right? Who here never learned this before? Never learned before. Okay. For those who have never learned this before, listen up. V equals to IR is a very, very important formula that you use to calculate either the voltage, resistance, or current. Let's say, for example, here, okay? Let's say, for example, here, there is a total of 1 ampere of current flowing here. Right now, according to the V equals to IR formula, I can actually find out how much is the total resistance here, right? How much will the total resistance here be if I voltage 3 and 1 ampere? It's 3, bro. Right?
Yes.
Right, so I know for a fact that this thing here will be 2 ohms and this thing here will be 1 ohm. How do I know this? Is because on top of calculating the overall resistance and the overall current and the overall voltage, right? I can actually calculate the individual voltage, individual current, and individual resistance. For example, I know that this 1 ampere is going to continuously flowing through these 2 light bulbs, right? Which means to say this guy is going to be 1 ampere and this guy is going to be 1 ampere. Using the V equals to IR formula, you can see that they all match up one at the end of the day. All components, including the battery and the overall resistance, will match up to your V equals to IR formula. Do you know what I'm talking about? This one here will be total 3 ohms, because the total voltage is 3 volts, total current is 1 ampere, and the total resistance will be 3 ohms.
So ohms equals to voltage.
Sorry?
So ohms equals to voltage.
Ohms is the resistance.
Yes.
Voltage is volts. Okay? Anyways, so there are 2 types of conductors, these guys. One is known as an ohmic conductor and another one known as a non-ohmic conductor. Ohmic conductors, for example, are like a wire. Okay? They'll have consistent resistance one. In the sense that if I supply more voltage, I'll have more current, even more voltage, even more current, even more voltage, and even more current. Right? You can see that the gradient is consistent. By the way, what does the gradient represent in a V versus I graph? How do I know what does the gradient represent in the V versus I graph? Very good. Change in Y over change in X, right? Which in this case here will V over I, right? Which is just a matter of V over I equals to R. In other words, my resistance is dictated by the gradient. So what happens if I have an increasing gradient? What does this mean? Good, it is more resistance. A common example of a non-ohmic conductor is like the filament lamp. You all know how a filament lamp works? A filament lamp was a very old technology that actually is super inefficient. Current has to flow through here where it reaches the filament wire. And the filament wire naturally has extremely high resistance. When it has extremely high resistance and current flows through it, what's going to happen? Yes, it will generate more heat. And when it generates heat, right, it will glow up so much that it starts to emit light. It will heat up first, glow, and then it will glow up so much until it starts to emit light. In other words, this thing works in the sense that electrical energy must first be converted into heat energy before it is converted into light energy. So like maybe 80 to 90% of the energy is lost to the surrounding one. And if you ever play with filament lamps before, right, it's super hot to the touch one. It's not like this lamp, right, you touch it, it's not hot. If you ever, I don't know if you guys even have a chance to see it or not. Filament lamps damn hot. Back then when we were younger, oh, one of you guys go get the drink. Hello? You sudah sampai ke? Level 1 kat GTG sini. You nampak ke itu signboard? Oh, okay, thank you. Okay, bye. Oh, this guy comes up. Nice. Anyways, if you ever played with filament lamp before, right? Me and Gilbert, we were young and dumb back then. I remember first time looking at filament lamp, I touched it, it was really hot. It was so hot that I accidentally the saliva dropped out, Then not like the big saliva, like some saliva and it landed on the lamp. It evaporated straight away, It boiled the water, the saliva literally boiled straight away. And I'm like, wow. Then now I'm starting to do it intentionally already. Two. Two.
What have you right now?
Yes, thank you.
Good boy.
It's for them. Then I started to, then I'm like, wow, interesting. I asked him to come over. Hey, Gilbert, come see this. Then can you imagine like the lamp is between us? Then both of us like two. But that was a big problem. What do you think happened next? No, electrical current is not going to touch us. No, even worse.
Exploded.
It exploded. How come?
The touch electrical thing.
No, nothing to do with electricity.
Oh, the price. Because inside, outside, different temperature.
Close. So guys, think about it this way, right? Imagine today I constantly spit onto one side of the lamp, right? This side will get colder, right? But then this side is still continuously hot.
So it's like boiling.
So one part is cold. Yes. One part is cold where it contracts. The other part is hot where it continues expanding. So eventually this light bulb just give way, right? So when it give way already, it will crack off. And it exploded into 1,000 pieces. And we got scolding. We were very young, probably like 4 or 5 years old. Yeah, because it exploded, bro. The core memory already. I just remember two. Then it's like two. Shit. It did. Wow, I tell you, everyone rushed into the room, No last time we got like all the table lamps one Last time don't have all this. Last time don't even have all this one. Not a lot one. Mostly table lamps with filled with filament lamps one. Two. Boom. Yes. Okay. So anyways, I just want to cut the bullshit short. This one has what resistance again? Constant resistance, and the other one has not just variable. Give me specific. Increasing resistance. That's all ohmic conductor and non-ohmic conductor. Cover this down.
Right there. Really. So weird. It's nice. Honestly. You.
Welcome.
Thank you.
Oh, you're back. Welcome back.
Oh.
L.
We. Well, I said with the video.
Video.
No, I mean.
Oh,
Like I was they want to see. Lanjut. Siapa bisa bisa bro?
Done copying or not? Done copying, do the questions at the bottom, bro. Actually, wait, before you guys do the question, everyone stop, listen up, flip to the next page. Flip to the next page. I want to talk about this. This one will continue next week because this one is damn long and got a lot of examples. Let me continue this so that I can give you guys homework this week. Listen up. Everyone, pay attention. So, in terms of electricity, right, we always deal with power and energy, right? Power's general formula was what again? Energy over time, right? From here, this is the general formula for power, right? In terms of electrical components, guys, it only depends on two things only, the power. It's dependent on the voltage and the current. And in fact, right, if you look at all your, like all these charges, if you look at the fine print, right, you'll see that the input voltage is how much and the current input is how much. And usually they'll write it somewhere in your computer charges. That tells you how much power is going to be consumed by your electrical devices. Okay, listen up, think about it logically. The only thing that dictates the power of any electrical device is going to be voltage and current. But from here, there's two other formulas that are derived from the Ohm's law formula. Okay, what's Ohm's law formula again? V equals to IR, right? Imagine today I substitute this V into this here. It will turn into P equals to IR times I, right? Which ultimately becomes P equals to I square R. Can you guys see this? Right? And if let's say I make I the subject, I equals to V over R, right? I substitute this I into here. It will become P equals to V over R, right? Which gives rise to the next formula, P equals to V squared over R. Okay? Dependent on what parameters is given to you in the question, you will use different formulas of power. Okay? But if let's say you say, I don't want to memorize any of the formula, then you at least remember these two. Because you can still find the same answer at the end of the day if you don't want to derive the formula. Okay, everyone? Anyone don't know what I'm talking about? Just the formula. This one relatively straightforward. What's the units for power again? Watts. And finally, the last formula I want to talk about is basically electrical energy, which once again is calculated. Guys, if you think back about this general formula, right, everyone pay attention, please. If not, you're all going to result to memorizing this here later on. Energy is going to be power times time, right? And just now we said that power depends on voltage and current, so it's essentially VI, right? Power and time. Do you know that this formula can help you solve back the electromotive force formula? Just now, what did I say for electromotive force? Can anyone remember the definition without referring to your notes? Can anyone remember the definition for electromotive force or not? Close, but not close enough. Electromotive force is defined as the amount of energy needed to drive 1 coulomb charge around the circuit. If I make this into V as the subject, guys, I'll basically get V equals to E over IT, right? Just now I said IT was what again? Wait, the first thing we started off. Our resistance. What? Q. Is Q equals to IT, right? So this one here goes back into the formula of this one here. You guys can see it or not? Hey, shit, where is it? Can see it or not? So if I know a lot of students, they always cannot remember this formula. You won't be the first and you won't be the last. Okay? If you don't remember this formula, at least try to remember this formula, because I think E equals to power times time, E equals to VIT, then V equals to E over IT is easier to remember. So you have a thought process downwards instead of using pure memory to remember, which I know most of you guys will not. Okay? Think about a process to remember it. 各位先生。
No. Yeah. It's like this small. Yeah, you should be. Oh, yeah, both.
Potential difference is the same as voltage.
What? Give me 6 hours and I'll spend the small for me. You get extra costs. I move for our side. She's There's a potential difference is voltage, right?
Yes.
Easy man. Oh, you make a paper. Oh, that's actually hard. I don't know. Okay, so it's
Hey, Al,
but
kamera video.
I want to see the shot.
Okay.
I mean, iron. Iron in that another one. For example, you have one video. And in my class. Yeah, what do you know? Yeah, we learn. I don't know, is it the same as brothers? It's great, we learn more. Just say you hate this, this one is keep on. Because you call we read.
I was surprised.
Wait,看
See this guy, this guy's connected with them put if you play this is my class.
你看什么？什么？我看了你给我你。
所以 Chloe
Oh my days.
You can see it's so nice. Actually, you can learn about that.
Other one like you didn't have to change the world. That's nice.
Spend the 9 minutes doing what?
Oh, you there? You hear me? The very strict code.
5 minutes and I said, I said,
Oh, we almost a real little ladies.
Yes.
Yeah.
oh,
Last time the one. The first one. No, I think it's
Guys, finish up the multiple choice. Everyone, listen up. On top of the 3 questions, on top of the 3 questions on top here, and the 3 questions on the bottom here, I want you to finish up the multiple choices, guys. And then we'll discuss the answers next week. Hey, did you hear what I say?
Yes. Finish this, then the mouth.
Did you hear what I said?
yeah.
What did I say?
That's very important.
Oh, sure, you guys will hear what I said. Okay, that'll be it for today. You guys can have a break until chemistry. Yay! Okay, Sarah, remember, okay? Transition metals are not colored compounds. Sorry, they're not colored. Only the compounds of transition metals is colored. And obviously, they act as catalysts and have variable oxidation state. For the period of a iron, right? You have to remember that this one is, oh no. This one is period 1, period 2, period 3, and then period 4. Okay, and thus it should be period 4. And for proton number and neutron number, you can find yourself. If you don't know this, GG. Anyways, moving on to this next part here, right? Which substance is a mineral containing largely calcium carbonate? I told you guys before, right? Calcium carbonate's name is known as limestone. So this one belongs here. Which substance is formed when impurities of the ore react with calcium oxide? If you refer to the notes, it's just known as slag, which is here, right? And which substance is called hematite? Hematite is essentially the iron ore, which belongs here. I think most of you guys get this one correct, right? Good. Okay, moving on. Next part. State two functions of coke used in the blast furnace. Guys, this question quite commonly asked in your exam, guys. There's two functions for coke. Number one, to increase the temperature of the blast furnace, so it's easier to extract, right? And easier to reduce the iron oxide. And number two, to produce carbon monoxide, which is a stronger reducing agent. Excellent, very good. So your answer should be to increase the temperature of the blast furnace. And number two is to produce carbon monoxide, which reduces the iron oxide. Bam! 2 marks. Okay, and finally, some of the iron is converted into stainless steel. Stainless steel, what's the use for? Utensils. You can write a lot of answers, but I tell you, I wouldn't write any other answer because I literally eat with the stainless steel every day. Is this how you spell utensils? Did I spell it wrong? Sales are like that. Okay, good. Spelling is not my strong suit. Okay, then move on to the next question, please. Okay. You know what utensils are? Fork and spoon. The fork and spoon. Sarah, can I help you? I almost
Good boy. Actually, no, it's good. 然后我觉得你应该给我一个like complete的方式是许换。
Thinking, having you can refer to the book, right? These are all in the notes. Everything.
Yeah. Oh, you know, my sister in your school.
Geophysics. Oh, I tell you what, I must give you guys some serious advice. Don't think about right. Oh, I want to study until masters. Then I want to do my thing. I tell you what, 9 of 10 people don't do what they study for. Geophysics lah, biochemist lah, what engineer lah.
No, he was like 3 years old.
That's nothing, bro. 3 years is nothing.
Wait, so it's the影响.
Why was very good? 3 years was nothing. No, I mean, what do you decide? That's all.
Me? Petroleum engineering.
Whoa! Why are you here? Are you here, Lewis?
Because when I graduated, all the gas prices crashed like crazy.
So what? What else is
So I was doing nothing for the whole year plus.
So when is the winter?
When 我读书的时候我做 internship engineering 要做 internship 的嘛，我在一个大的地方 internship 的 You know what that is? Sakura 的展览 It was next to Petronas only, but Petronas 第一个大，第二个就是 Sakura 的展览 Then after that, when 我 intern 的时候我已经知道 shit's gonna hit the ceiling because during my last month there, and oil and gas prices 开始下降了 So a lot of people they were having meeting and then they were like, oh, we're gonna cut costs this project. This one oh, let me go this whole method they pay me like $500 a month before.
Huh? They pay you?
Yeah, internship 啊。
internship 有
Nothing cheaper than a janitor bro.
No,你过来看，你过来看。You come.
哦，
You come see. You see his experience bro.
我
我是 experience 什么的，要等experience。
喂，这条水很 experience 的。
喂，
哇，喂啊，做很多嘞喂。
and you know he's married to a Japanese woman, and he is a Indonesian what translator interpreter in
What?
Singapore.
What the? My bloody working overseas for what?
Fuck is it?
Now 是为什么看人家want to become lawyer? She could become lawyer.
还是啥？雷士的一个 barrel 要卖至少60到70 USD per barrel。When the oil prices before the oil prices 一个 barrel 给你120块。
That's crazy bro.
然后 oil prices 1啊，它就一直下到25块。
就是在 oil 是不值钱的东西，那东西
不值钱，因为不赚不值钱的钱要亏钱，因为那些还有 contract，因为
我们还是要 supply
我还是要 supply 给你，每一个 barrel 我 supply 给你，我中间40多块 ，and then the barrels are not by cut for 1000啊，500是吧？一million barrel，一个 barrel 就45块，一个 million barrel 就45块，所以他们会 contract 就消嘛，消，不要了，不要做了，那个时候就是我们的。
所以啊，这样你是那个学校
现在那里怎么去做？现在我去我洗了30块 bro， 你会做吗？现在我有儿子了，有人养了，30块我吓死了，对。
喂，
然后你卖给我也对啦。
OK，
And my friend bought a 460连续。20多钱嘛，跟你多少钱？我的是 right。400cc。
What are you gonna study?
Hello everyone. Don't stop doing your work. Do not already.
Wait, so did you basically do a wasted now?
Yeah, we still whatever. And I didn't really like it anyway lah. I was right. Borderline classing.
Well, you give on more than
That's what it tells you 啦。我妈妈就这样跟我讲啊，懂得多一点啦，懂多情诶，
讲不多情诶。
That's crazy.
爸爸was doing I so let's say 啦，我 graduate 不要讲多啊 ，maybe 6年 before I actually graduated， I would have been I would have the skill set that the company needs during the crisis 我就 relax， crisis over 我就可以去做了嘛。我要赚钱了，我出来。
你上次几岁啊 ？During the crisis，
24、25岁。
哦，那是吗？
我可能坐在家里不能听。
That's just 7 years ago.
Oh,
are you not?
I'm doing.
对，是有点。
8 years ago.
I'm
So you might be.
Yeah.
What you work right now? Huh? What you work now? This is your full time. You only have this only. Huh? You don't make less than 3K.
What?
不是，你说一下这边有多少个人？
今天的这个 class 不可能包括3K 了。
你一个月学费200块。
Bro， 3K 我死了，我怎么养孩子 ，bro？
我
bro，
Got 2 kids bro.
还要养狗啊 ，bro。
还有狗哎，有
Two kids, one monkey.
很少 ，bro。
1、2、3、4、5，这边都有9个人了。哦，那一个 Sarah 还有一个 ，that's 11 people。
如果啊，
你的是多少
if let's say 啦 I'm just earning 3K 啦 ，I die I kill myself right now。
You got physics classes? You got 2 centers.
2,000.
No, just starting off now. About like 5 students there now,
5 only.
but they're all private classes so it's like a different calculation.
They're all what?
Private classes.
哪里有3000？
How much is
差不多3000，那他这边都2000多了。 还有 physics 呢？你所费、aircon fee、电费、水费、电费 I mean the shop fee, right? And too cheap, eh? What's your rental like
1.6K only. Yeah.
Eh, how much you rent?
downstairs is?
It's 1.6. Yeah.
You can't just calculate like this.
Really?
1、2、3、6K，还有 maths 给我吗？你 run as a，因为那个地方人。Yeah, and private classes. Year 9, year 7, private student.
Okay, done with the second question.
赚1000 okay for physics and chem. Unless the one from 2K 2.4K, minus the let's say 10K, but 一定是 for 7K. Stupid things.
Let me just tell you 啊，我一个月的 commitment 啊，就是说我不是我用的钱啊，我要给出去的钱啊，都5个 figure 了。对啊，就是说，let's say 啦，let's say today right this month 啊，I only have 9,000 income right. I have to take from my savings.
Wait, your own commitment.
Yeah.
What? 10K.
Everything, bro. I tell you lah, later when you grow older, you
How many pieces of diapers does your baby use?
It's not just that lah. Everything there.
Yeah, I know.
For the pay my parents, pay my house, pay my rental, pay my shop rental, pay my other shop rental, pay for my maid, pay for this, pay for that. I haven't even 我都看不到钱了，我跟你讲。I see anything 啊，一个月啊，至少啊10多千。
我说你还跟我买这个？What?
什么东西
I mean,
She feel bad now, she feel bad now.
Oh,
but so this was the misconception that I had when I was young. You know, I asked my mom if let's say if I'm older, I asked my mom this. I say, if I want to live a comfortable life, how much income should I be earning? My mom told me 10,000. So that was my thought process. Oh, 10,000 is good enough, right? I tell you, at your time, when you guys graduate, let's say for yourself, okay, let's say right, your parents rich one, they give you a house, give you a car, 5,000 also enough already. 5,000, enjoy life, bro. If you're alone, but once you have more commitment, your parents are gonna grow old, you're gonna have to take over the loans and you have to repay and this that. I tell you, 没有 if let's say like your income, your let's say you marry someone already, right? If your income is both of you guys are income less than 20,000, you're gonna have it rough, man. I tell you. It's like it's gonna be rough.
You earn 5 figures. Cost not 100,000 over 5 figures, that's stupid. So you do earn 5 figures? What? How? It's recording. How? What? It's not adding up, bro.
Do you?
You're stupid, are you? What's it adding up?
But kind of my disposable income 可能一个月我可能有2、3千块用吧，2、3千块用吧。
That's enough what? 2、3千 as in like
For my own food.
你没有算进去啊
My own food like 我 I have like maybe 2、3千块 disposable income 用吧一个月。
That's okay what? No savings. That's not okay. 2、3千块 as in 他算了基本的 not the wife and not the kid. Are you gonna tell your wife I only have 2、3千? I'm not gonna pay you this dinner. You're gonna AA. What the fuck are you thinking, bro? 自己一个人有赚5 figures 咩？
变成快乐死了bro。那你可能讲，外面那些人有家庭没有5 figure 的可能我跟你讲。我讲generally like you see the people around you 我不要讲like好像那些 B40 let's say right B40 我给你3000块，我曾经遇过一个马来人5000块有3个孩子 ，and the wife don't work one， 我看看你怎么样，看你要怎么样 live your life I also don't know but they can
KL, 4 people
in KL. I tell you, I don't know. But it's different because you stay in a more expensive area. Maybe they'll stay in a cheaper area, so the food there might be cheaper also.
Every area.
I don't know.
but you told me 5K a month. Then I count 3 kids are wow. And I'm like, the wife never works some more. The guy work only.
Oh, my food is like pretty rich. If you go to
But what I want to say is, right, actually, it doesn't matter. Your life, your life is very elastic. You will adjust to according to what you have.
Bro, 哪里可以？我真是算不到啊！那里找到多5000的，那1、2、3、4、5，我们算10个人。你的人都还有电费和水费是，
This is a solid aluminium. First question, how come it's it's not electrons line, is it a total survey? It's electron line something cannot. We don't know. We can see. Level 4. No free moving electrons. The keyword is write it down. Free moving electrons. No free moving electrons. Huh?
是还教的，他们全部给我来讲，我们你是老师跟一个老师那个。
Then it says that it conducts either when voltage, you know what voltage is? What's voltage?
Let's see.
Okay, something that has already melted like hydrolyzed, I think a metal and melted to be considered molten sigma. Right? All that is dissolved in molten cryolite. Okay, and say wine. And it's only 2 months. You must say long. Solid aluminium is a poor conductor because it's all free moving electrons, whereas molten or molten cryolite is free moving electrons. I can't really say 2 months.
不像少，15 ringgit per hour. So you put teachers hourly?
Yeah.
How much?
Depends.
Penny.
Oh, that's a
private.
That's a private thing, right?
Sure, but 15 if you go out and do
Yeah, teach or not? You graduate, you teach for me, you pay me $50 an hour.
50.
Better than selling.
50 oh 50.
Minimum 50.
No, but if you go out part time, 15 ringgit per hour is really a lot already.
Yeah, I know. You try it, you go outside.
You're not teaching ah,
You try to go outside, you find right. Anyone that hire you less than $10 per hour.
It's so much eh.
But that's our mind. Not like that.
Oh, what can I get you? But 他在他这个是算这里才有5 figures。I still know how to get by, bro.
I will just teach on Saturday, for Saturday is still okay.
有几个 branch？2个。
So,
branch，你讲你另外一个 branch 才开始 build up 好，才开始有人进来好。
right, online classes also.
Yeah, exactly. 我哪里录？把这 students。
Amy, Claudia, who, you know that?
Yeah, with private classes.
Yeah.
How much are private classes?
Wow.
Hey, how are you getting 5? Is it like barely 5 or like 5?
It fluctuates on.
会上下。But is it always 5?
It's better not for C5. If not, I'll be running on deficit, bro.
The wife doesn't want. That's right.
Of course,
Oh, that's.
she work.
That's okay, what? Right?
Luckily, my wife works. Thank God, hallelujah. If not, I stress. How about you here? Oh, she's good. She's climbing the corporate ladder right now. She jumped from UOB to EY to Maybank. Right now, she's in HSBC.
So it sucks.
Yeah, not banker. She's a back-end product manager. So
Oh.
like May, right? May app. She's the one that decides, oh, this thing must place where, that thing must place where.
That's what put them.
Well, I think my wife knows. Hallelujah, Jesus. Stress all the way here.
UOB. When was she UOB?
Long back, so I should look right. Yeah.
Now is working there.
Really?
Yeah.
Actually, every department also same one.
My mom was working city at first.
Huh?
My mom was working city at first.
City?
City.
What city? Oh.
Then UOB for it.
Is it? I didn't know. Okay, everyone, time for question number 2. My friends. Okay, guys, check your answer for question number 2. First and foremost, in this question here, you see the word poor conductor of electricity. As soon as you see something can or cannot conduct electricity, is mostly because of the free or non-free moving ions, guys. Which is exactly what you need to write here. You're supposed to say that solid aluminum oxide does not have free moving electrons, while molten or dissolved molten cryolite has free moving electrons. Same lah, I just told you, right? Ion. What? Ionic bonding? What ionic bonding? Outside is an ionic bond, only in molten. Yeah, but your keyword is because of free moving electrons. Huh? Yeah, doesn't matter. I tell you already, don't care about the marks, write what you know. Okay? The free moving electrons, one have free moving electrons, the other one does not. Okay, anyways, why is a solution of aluminum oxide in molten used rather than molten aluminium? Why we use cryolite again? Yes, to lower the melting point of aluminium oxide to reduce cost at the end of the day, reduce cost of production. Bam, another 1 mark. Another melody? She copy you.
Oh yeah, she. Oh, she went like pencil in her hand.
Okay, anyways, moving on to the next part. Explain why carbon anodes needs to be replaced periodically. What's happening in the carbon anodes? It will corrode and react with good and form. And for what? Carbon dioxide, right? Because carbon reacts with the oxygen to form carbon dioxide and corrode. Do you know what corrode is? Corrode is like acid melted away, the kind. Corrosion. Like acid, when you put it onto something, it will corrode it, right? If you put it, yeah, something like melt lah, but corrode, destroy or damage, usually metal, slowly by chemical reaction. It's a form of corrosion. Rust is a form of corrosion also. Huh? What the fuck? I mean, I know lah, it's general. This one corrode, everyone know or not? This one. This map is called corrode. I play this game. I'm shit lah. I'm damn shit lah. It's because I have a job, that's why I haven't grind this game only, okay? If I grind this game. Okay, anyways, yeah.
So it's horrible.
Okay, can everyone state one reason why graphite is used for electrodes? for the electrodes is that it's a good, give another reason why. One reason why graphite is used that way. Sometimes in this cryolite, right, in this extraction of aluminium, they'll put graphite electrodes instead of carbon electrodes. How come? Why do they do that? Sometimes in the extraction of aluminium, instead of using carbon electrodes, they'll use graphite electrodes. Good, because graphite is inert, right? It generally will not react, right? Graphite is inert. It generally doesn't react, right? But it's more expensive, right? So people they think that replacing it is better, at least it's a better running cost.
Oh. I think that not done. I'm how will that feel? I'm doing I'm using on Shopee.
So what's the difference between graphite and aluminium?
One is less reactive than the other, but both will serve the same purpose. Huh? Of course, graphite.
No. That's it. That's what I meant.
Okay, anyways, moving on. Aluminum is used to make food containers because it is resist corrosion. Explain why it does not attack. It's not attacked by food. Actually, I don't know why this question is here. It already say it resists corrosion. Then explain why it is not attacked by acid. Yes, very good. Aluminium, although it's relatively high in the reactivity series, is generally non-reactive because as soon as I produce pure aluminium, expose it to the air, immediately it will form a very unreactive layer of aluminium oxide. You repeat again what I said just now. Wow, very good. You can really multitask. Amazing. You're safe this round. Okay, good. Right, so aluminium oxide. Aluminium is generally used for food containers, guys. And you're just going to say that, I guess. You're just going to say that. Actually, I don't know what to say for this one. What should you even say? Aluminium produces a protective layer that does not react with the food. Aluminium produces a protective layer of aluminium oxide to prevent corrosion. Prevent corrosion is in the question again. That is unreactive. Yeah, I guess so. Good. In fact, now that I look at the mark scheme, it's damn stupid. It literally writes the same thing. Resist corrosion, which is already in the question. You all know the general rule, right? You're not supposed to write anything that is already in the question. Like in this scenario here, if it resists corrosion, you cannot write an answer that resists corrosion. Like the reasoning cannot be from the question itself. But the mark scheme gives resist corrosion, which is stupid. Anyways, moving on to the next part here. Give two properties of aluminum which makes it suitable for this use here. First and foremost, this is something that is conducting electricity. Aluminium conducts electricity. What? Why do I feel like I'm spelling this wrong? Electricity. Oh, my brain is shutting down already. Seriously, I can't focus already. Aluminium conducts electricity, and also because why? Why do we use aluminium in the overhead cables? Why don't we use iron instead? It's strong. It has a relatively high strength to density ratio, guys. It's generally low dense, means to say it's very light, but it is relatively strong, guys. There's a high strength to density ratio. And obviously the steel core is for what are we? No. Actually, this one, the outside is conducting electricity already. So the steel core is actually to increase the strength of the wire. In fact, right, if you open up any of the high tension cables, you always see that inside is one steel core. It's because it wants the wire to have a certain amount of strength. If not, it will break upon itself. Oh, sorry, were you copying? Okay, last two questions, hurry up. Hey, is this the last question already?
Catalyst. No, bauxite. Oh my days, bauxite is aluminium though.
Bauxite is the ore of aluminium, my friend. You were here, right?
You know what you asked me? Bauxite is the catalyst.
GG.
What's the catalyst name again?
Molten cryolite. Actually, it's not really a catalyst. It's something that reduces the melting point.
Yes, it's okay. Oh, for dog and cat. Dog and cat. The cat's so cute. The cat is so bad. My cat is 1 kg. And my cat is also 12 kg. That's 2.6. 2.2. Oh, there's an underwear.
I want the radiation to go into
Wait,
然后我跟他讲说，然后我跟他讲说，只要追进去，是啦，我刚才这次问他，让他还骂我的王司机了。然后最近我又跟他讲了，就问人家盖谁盖子？哦，因为你讲的那个 plastic 哦，它弄坏了会 thermal expansion 啊。你跟读书是不是那个？我会懂了，你的 plastic 有水面里面，I'm so sorry, you're so sorry, I'm so sorry that I'm in the present of you. That's why we are breathing at the same oxygen. 你懂吗？然后全部人看见了，然后我的 I don't care, cause I don't know. 然后我就准备从后者，然后我就在解决的，然后我女生才对，她屌我的嘛，就所以我是能力比她，我女生是 radiation，没有 radiation 跟 radiation。他骂我，他讲你用什么microwave，他讲不是玻璃的。Yes。然后我就跟他们讲。
Because all live in the same area as me.
然后就跟着那一来个听到吗？那一来个在那笑话的，我。他热水了。有谁呢？那个去那个跑过来，那个作业就用了，不必了。是是。哦，这就那包括去看的。
No, maybe like it is not just school.
一个是游泳啊，跑步。因为我那个去知道，跑出去。跑 long distance 的。
I don't know. No, but that's a she's not the river.
我那天我很 pissed off 啊，真的很好笑啊。反正搞回一整天。Bro, he told me microwave for like thermal expansion。然后你懂他讲他被放进去之后那种 expansion，他heat 了过后，他拿那个盖去盖住他的食物。你觉得，这个 plastic 那个传点的，我放进 microwave，它是不会 thermal expansion 的
No.
right？Exactly。
For
microwave。
Okay, so you know how microwaves work. Microwave literally provide energy to the water molecules in the food, then it heats up. Plastic 都没有 water molecule.
Exactly。我的朋友哦，那时候他去盖着他的食物，让尽量盖着。他跟我讲他怕 radiation 进他的食物，然后我跟他讲，然后我要跟他讲的时候，他骂我，OK，我不要跟他讲了。他这过后他就he took off the cap, I was like, the lid, I was like, what you take out? My mom said I'm breaking the plastic because thermal expansion in there. And I was like, there's no thermal expansion in there, bro. There's no water. Now he got pissed.
He started shouting that I'm so sorry I'm in your presence or something. I'm so sorry that I'm breathing the same oxygen as you. I was like,
What a psychopath.
yeah. 然后他讲哇，然后
那个朋友不可以这样。
然后我就 like what the fuck， 然后他没有他拿了出他的 steam 拿住嘛，他盖他的食物，那个 steam 应该只是弄到他的那个 expand 的 heat 嘛，right，懂我的意思？他拿他的食物出来很烧嘛，他盖起来拿那个 lid。
Whatever, make it preserve your heat.
I don't know， 然后他讲放进 micro 是 thermal expander， 弄到他的那个 plastic Y 这样子。But isn't it the action that you do and you cover the heat going up？
它那个 plastic 会歪啊，是 assuming the container is sealed right， 里面一直 hot， 所以它 pressure 高，所以的话，
对，然后他妈我在那边喊，全部人看着他。那个业务员就在问我怎么，然后跟他讲那也很少。必的。欣赏。
Guys, you have 5 more minutes or less to have the last question.
Thank you.
Waiting for Christmas.
No. Electrolysis.
你可以跟着他谈，真的，你太过了。
I just walk 400 last week. I can't see anything.
We're sleeping too much already, bro. You literally come here 一个礼拜来，一个礼拜不来，一个礼拜来，一个礼拜不来。Thanks.
开玩笑，开玩笑罢了，中奖的。No, thanks. You know, my little something that way.
I mean, what's about those guys like once?
Yes, by the way.
There's still the right table. I mean, okay.
Was it? Oh, knees. Yeah.
Sleepy already, ah. 哦，也可以打我。
我打到很轻了了，我是一直很轻，因为我们中午来看。
Four of aluminium.
哇，也真是很重。我会工作了，也会怎么样？我带身体丢。哇，这是真的。都做了地方让人家去。It sucks. 所以你的 police。
要不是 WiFi 信号不好吗？
信号不好，我信号不是 data 信号不好，是电话信号不好。啊，对。
如果这个 electrolysis 来的，你个也不会做。And no use.
We can refer to the notes while waiting, read through it.
Oh, that's true. Yes,
Some form of information.
不要吵了。
That's true. That's true.
是
Very good.
Bro, how crazy
我要多女朋友。
你信讲啥？你少
讲讲
女朋友，
讲讲，
你信讲你是大美女朋友。你们
啊
的
讲讲讲，
啊？I do video call every day.
What?
What?
Wait, are you doing this?
He does me like girl, bro.
You trying to steal me, bro? Hey, show.
It's scam people.
看手看，你在看手看。
哇，
So you're meeting with someone.
哇，1 2 3 4 5 6 7
really good girl.
Disgusting. That's disgusting.
No, it's like.
I think it was my friend and
No. You see,
Yeah.
look at the duration. We look at the duration. 56 seconds.
Like, he seems like texting me about a super random sort of thing.
19 minutes. That was getting so fast.
It's not. It's not.
About myself.
14 days ago. A few seconds. Me? No, iPhone fucking dog. I think the question was
Definitely not a song.
没有，你不讲明天破妈咪？
Okay, everyone, shut up. Let's go through the last question before I let some of you animals out. Okay, first question. Everyone, shut up. Name the ore of aluminum oxide. Obviously, it is going to be known as
Bauxite.
bauxite, however, alright. Good. Then name the electrode. What kind of electrode should we use?
Graphite.
Either graphite or carbon, both is acceptable, right? Then aluminum oxide dissolves in molten cryolite before it's electrolyzed. Why do we dissolve it molten cryolite again? Because
Lower melting.
it lowers the melting point of the aluminum oxide, right? And ultimately improve, you can also write this, improve the conductivity.
Is cheaper.
No, it's not. You cannot write that.
Yeah.
Improve the conductivity of aluminum oxide, guys, because this is molten cryolite. Okay, and the anode and cathode, you can literally refer to your notes. In this case here, it will be Al3 plus 3 electron becomes Al. Right. Huh? Oh, I mean, I looked through this just now, right? The way to, if let's say you are confused, the first question you want to ask yourself is if this electrode anode, right? Is it positive or negative? If it's positive, it should attract the negative ones, right? So I know that this is going to be there already. And I'll do the same reasoning for this one also, right? Then the next thing is you need to know that this thing will turn into this thing and this thing will turn into this thing. So it's a matter of placing the electrons on the left or on the right side only. You get what I mean? Yeah. Okay. But anyways, it's literally in your notes. You can refer to your notes. Okay, then finally, the next part here, place the element of this one, increasing reactivity, it must be which one first? Iron, then carbon, then aluminium. And I mentioned this, guys. I think I mentioned this in class before, right? How come we can use the carbon reduction process for iron, but we cannot use it for aluminium? Why?
This is really hot.
Huh?
Then the melting point is really high.
No.
Reactivity, you know what?
What about the reactivity?
High,
What's more high?
higher than carbon,
What's higher than carbon?
aluminium.
Good. Guys, if you refer to the notes that I mentioned, very good. If you refer to the notes that I mentioned, right, guys, carbon is basically here, right? You can use carbon to reduce zinc oxide, iron oxide. There's no such thing as hydrogen oxide and so on, right? But anything above carbon, you must use electrolysis already, right? Remember or not, boy?
Yes.
And thus, that's your answer for that part there. You're supposed to write this down, guys. You're supposed to say that carbon is more reactive than iron and thus can be used to reduce iron oxide.
I mean, that's how we do it.
Okay?
Huh? It says this is two stream but salary. That's
Wait, 写了吗？你 answer?
Yeah.
Okay. What's the name of the ore? It's definitely hematite, right?
No, outside.
What the
Wait.
fuck?
No.
Bauxite for iron oxide. Aluminium also bauxite. Iron also bauxite. GG. Yes, hepatitis. And this one here, literally, you can refer to your notes. The complete combustion of coke would be what? Good. Carbon plus oxygen becomes carbon dioxide. Balance already, this one. Then, production of carbon monoxide from carbon dioxide. CO2 plus carbon now becomes carbon monoxide. Is this balanced? No, you have to put the 2 here. Then reduction of iron oxide. What do we use to reduce the iron oxide right now? Good. Fe2O3 plus the carbon monoxide becomes, then you balance the equation, which in this case here will be 3, 2, 3, guys.
Yes.
3, 2, 3, and the formation of slag. You guys probably need to remember what's the equation for slag, guys, because it's quite commonly asked in your exam. If not, you just remember that you're supposed to react the calcium oxide with the silicon dioxide, and then you just combine everything together, CaSiO3. You need to remember this,
KCO3.
It's K.
KCO.
Oh, okay. Casio. Oh, yeah, okay.
Funny, it's not a joke.
It is, Casio. Casio, the watch brand. Oh,
Okay.
I didn't think about it that way. Good. Yeah, but if you don't remember this, you remember this one, because this one has to react with sand and the calcium dioxide, calcium oxide, to form the slag.
Yes.
Okay, go on, guys.
Okay, that will be it.
Dismissed.
You are dismissed. See you all.